Hi, I'm Jeff, and this is Lithic Metals. Today I'm going to be refining a small batch of carat scrap. We're going to pull some gold out of here. I have a mix. There's a mix. There's some 10 carat, 14 carat, even a small piece of 24 carat. In the bottom here, a little like 1/10. But we're going to guarantee that it's 24 carat by refining it one more time. Doesn't look very attractive right now because I've already hit it with the torch just to incinerate it a bit, remove any grease, grime, dirt might be collected on that old jewelry. And for this process, I'm going to be doing it through inquartation. I'm going to inquart this gold, which means I'm going to take and make an alloy of 25% gold. So 1 part gold to 3 parts base metal. So since there's 10 karat, 14 karat gold in here, there already is some base metal in there. So you have to calculate for that. According to the weights of these pieces, we have approximately a total of 10.7 grams of pure gold mixed in here. And to get that 3-to-1 ratio, I need to add more base metal. There is, as I mentioned, there is some base metal in there, so I subtract from the total I need. Turns out I need just over 20 grams of extra base metal inquarted into this material. So I'm going to add some pure silver crystal. I already pre-weighed it. And here we are. So this is going to be our mix right here. I'm going to pour that into a crucible. We're going to heat it up and then pour that into shot. So give me a second to resituate the camera and we'll get right to it. Right, then we're all set up. I have our carat scrap and pure silver crystal all set here. We're going to make our alloy. Let's get our fan going here. Gets a little noisier, but it helps to breathe properly in this type of experiment. For this little bit, I don't think we're going to need a big torch. I'm just going to use a small map gas. And this will be just a little bit over an ounce of material, I believe. Let me do the math. Yeah, a bit over an ounce of material. This torch should be just fine. We're going to melt it down, stir it up, make a good alloy, pour it into our water, and create some carat, I guess it is carat shot. It would be 6 carat. Is that right? 25%. All right, let's get cracking. I want to heat up the dish. I don't want to just stick it right on the material, on the metal. I'm not trying to melt the metal per se right off the bat. I want to get everything that the metal touches hot. I'm going to work on this dish first. A lot of times I'll preheat the dish before I even put the material in. I'm going to call it right there. I'm mistaken. It's about 10 degrees colder in here than normal. So I think typically at 72 degrees, I could knock this out. But I'm going to switch gears. Might have seen a little pop go on there. That was a little bit of borax cooling down real quick. I'm going to pour this water off here. All right, we have our new alloy, and this big chunk is what happens when you get complacent. I'm used to doing a kind of larger batches lately, and I didn't let my water cool down as far as I should, and this is what I get, a big blob instead of nice tiny little pellets like I'm supposed to be getting. But yep, it is what it is. I could remelt this down and go at it a little bit more, re-pour it, but I think we'll just attack it as is. Maybe next time I'll learn to check all my boxes before I proceed. Not jump the gun. This is about the ugliest shot that I've seen in a while. We're gonna make it work. All right, well, I'm gonna get set up in the fume booth, and I'll meet you there. All right, the next step of our process is to dissolve the base metals using dilute nitric acid. Well, let's just get it going, and then I'll briefly explain it. I'm going to turn our heat up here to medium high. And over here, I have some rinse water from a previous experiment that I'm going to utilize right here, just to cut down on our waste. I'll add the rest later if we need to rehydrate this. All right, our heat is up. We're going to get that cooking, and I'll briefly explain what we're going for here. The reason we mix the alloy to a 6 carat to a 25% gold to 75% base metals ratio is that once we mix it in that alloy, it creates a framework where obviously there's one molecule of, well, roughly there's one molecule of gold versus 3 molecules of silver or copper. And that allows, as the silver and copper dissolves, that allows the acids to weasel in all the nooks and crannies in between the atoms and to start dissolving all those particles of of base metals. So as this heats up, we can already get going. Let's start adding some nitric acid, and that is going to create dilute nitric acid. We can start with a fair amount right off the bat. We don't have to worry about, you know what I'm going to do? I'm going to spin this around. So it makes it easier to add our nitric acid. I'm going to start with about 5 mLs. 7.5 mLs. We'll just let that go. And I'm going to try to bring this to the front a little bit. Give us a better view as it goes. Now, as this solution starts heating up, it's going to turn to a very fine light green eventually as it really starts to pull that copper. And it's mostly silver here. If it was all pure silver in there, the solution would be relatively clear. Since we know it was karat scrap, it was bound to have copper mixed into that karat scrap. We're going to see our solution turn from a light green to darker green to a blue, depending on the amount of impurities, or I call it impurities, but it's base metal. So we'll let this go for a little while, and maybe we'll stare at it with the camera for a little bit in high speed, and yeah, and I'll let it cook for a bit, and I'll check back with you when it really starts to evolve. And I apologize for the last clip right before this. I just played it back. That the audio sounded terrible. Hopefully it isn't too horrible, but if nothing else, you can mute it, because listening to me probably isn't all that fun anyway. Well, you know, and if you do have fun, I didn't want to have to do this stuff, but apparently it's a must. If you do have fun, if you do enjoy this kind of stuff, please hit the like button. You know, that's going to help grow my channel and let me know that there's interest out there. Please subscribe. You know, if you're watching this, you like this stuff, hit that subscribe button. What do they say? Punch the bell so you're notified. And that's a big help for me, because as I grow and I see that there's interest, I'll put more and more videos on there, and we'll try to get better detail and better camera and audio quality, and maybe I'll upgrade from this potato that I'm using to record right now to a better camera. I have a couple GoPros and all this other stuff, but this seems just to be the easiest for right now. But anywho, I digressed again. So let's follow this for a little bit, and we'll see as it heats up. It's going to start to bubble and change colors. We'll watch it for a little while. Right, well, our solution is coming up to temperature here. I want to check that real quick. 157 degrees. I like it at about 165. And then at the end, before I pour it off, I turn it up to right below boiling temperature for the solution. And it helps with any platinum group metals that are in there. Anyway, let's add a bit more nitric acid here. About 12.5 units right now. All right, we'll let that work for a bit and check back when we need to add some more. Our reaction's slowing down. A good portion, the majority of the base metals have been dissolved out, and the acid's working hard now to get in all the little nooks and crannies. There's still a little bit of fumes coming off, so I can tell it's still attacking the base metals. I just added another ml of nitric acid, which puts us at a total of 32 mLs right now. So there is free nitric in this solution, and I think we'll just give it a little more time to work off. And when the reaction finally does fizzle out, I'm going to pour this solution off and start fresh with fresh distilled water, and we'll add nitric to it. If it stays clear, we'll know that we knocked out all of the base metals. If it starts to turn color again and show more fumes, we know we just got to keep working at it then. So I'm going to give this a little time to work, and then when it fizzles out, I'll turn the camera back on and we'll go to the next phase. Well, we're at the point where our reaction is slowing down. One of two things are going on here. Either we used up our nitric acid, or at least the vast majority of it, or the base metals are getting so sparse within our alloy that it's just not a lot of reaction, because it's just taking a little while for the nitrates to penetrate all the crevices and get in all the nooks and crannies. But to make it simple, I'm just going to pour this solution off, and first I'm going to dilute it a bit, and then I'm going to pour it off, put it on the side, just to make sure all the nitrates are used up. I'm going to throw some silver in there and let it do its thing on that little piece as it sits overnight. But then I'm going to move on with our experiment by filling the vessel with fresh distilled water and adding fresh nitrates. So let's get started. I'm going to lift this hood up. It's going to get a little noisy probably here, but get it done. Catastrophe. Well, I'm going to assess the situation and see how bad we got. At least we didn't drop our gold. Give me a second and I'll get back to you. Alright. And like magic, we're all cleaned up. That was wonderful. I don't know what I was thinking. I had a few things positioned wrong. I got that fixed now. That vessel was a little bit heavier with that big glass bottom than my normal beaker. I don't know what I was thinking, but that's part of the game. That was my first tip over that I've ever had, though. Hopefully that won't happen again anytime soon. And for half a second, I didn't even see it happen because of the... I'm going to close this. I didn't even see it happen because the camera's in my way. Gosh. I might just edit that out, but truth be told, I should probably just leave it in there because that's part of the hazards. That shows you how dangerous this could be. You know, I had the glass shield up, but it's still high enough or low enough that it's protecting my face, so I didn't get splashed or anything like that. Luckily enough, it didn't splash anywhere that I could tell other than in the pan, in the drip pan. So I cleaned up lickety split. It wasn't a lot of material. The paper towel that I used to clean that up, that is now in being saved. I will recover. It's not a lot of silver that was in there, but damn it, I'm not going to lose it. So, all right. Well, I'm going to get back to it now. Back to our plan. I rinsed our gold out. Good to be able to see that. We're getting close to the color we're looking for. We want that dark brown patina. It's getting there. It's getting there. All right. Let's just get busy. While that heats up, we're just gonna get the acid going. I'm just gonna start slow with 5 ml. I could put
20, 50 ml in there, it would be okay. Oh, actually, I got a little used distilled water as well. Drop that in there. That had just a little bit of nitrate in there. Turn this heat back up.
All right, now we can let that do its thing for a little bit. Just 1 second.
I'll show you. Thankfully, we were able to save the vast majority of our solution. Much less poured out than what could have. Thankfully, it's a very tall
vessel. All right. Is there anything else I should talk about? Not too much. Well, we'll know as this heats up and the nitrates start doing their thing. If there is, the silver isn't as noticeable. We'll still have fumes, but what really gives it away is the copper that was in some of that alloy, in some of that scrap jewelry, changing the color. So if the color of our solution tints out to a light green, that's a dead giveaway that we still have. That we still have some work to do. So let's just give it some time. And either way, I'll check back in when it heats up, and we'll take a look at it. See you then. A couple of minutes ago, I said something like I could put in 20 mLs or 50 mLs of nitric acid and it won't matter. Well, it doesn't matter. At this point, this solution is okay. If I have free nitrates in this solution, I can pour that off. If they're not going to be used, I can pour that off and save that solution for the next process or for a different process. In our next steps, when we switch over to aqua regia, we're going to be very careful with the amount of nitric acid that we use. Just like in the jar that we poured off earlier that I spilled, or at least knocked over, I didn't want a lot of acid left in there. I am going to drop some silver in there just to make sure that it gets eaten up if there is any left. But that's because now I'm going to pull that silver back out of solution. But in this stuff, if I don't use it, I'm going to pour that off, keep it separate, because the vast majority of our silver, of our base metals, are already pulled out of this material. Right now, we're just getting into the fine little spaces at a molecular level. So but the vast majority is in the solution that we poured off already. Yeah, with all that said, I'm going to add a little bit more nitric acid right now. Perfect. 159. Perfect. let's let that reaction work, and we'll check back in a few minutes. Alright, it's been a couple hours since we changed out our solution, so I'm going to do it one more time. Obviously we have some tint color, some bluish green tint to our solution, so we definitely pulled out some more base metals, and I'm going to do it, switch it out again, and we'll observe and see if there's any color change in the next round. I'd like to avoid another catastrophe, so I'm going to change my method a little bit here. I've been adding nitric acid to this solution, so I know there's still free nitrates in this solution. So I will be saving it, and we'll be using it for the next batch. And it would be fine just to pour our water in and just get to it, but I'm going to rinse this out real well so we don't have any carryover of the solution, just so we can be clear on the color. Look at it real quick here. Now we're getting somewhere. This is the color we're looking for. We want like a bronze patina. Our distilled water. 200 ml. Just going to shake that to the front so we can get a good view on it. I'm going to dose this pretty well. Put in about 20 ml. Put our lid back on and turn the heat back up. Let this go to town now, and when the reaction progresses, I'll give you an update. Well, It's been about 3.5 hours since I swapped out our solution, and I've worked it pretty hard. The temperature's really hot right now because it's evaporating, so I'm gonna add some fresh distilled water and pour this solution off. I'm not gonna save it. I'm gonna pour that in our silver nitrate container over there. I don't know if that's really what it is, but that's what I'm gonna call it for right now. It's been a long day. But yeah, so I'm gonna swap this around. I'm gonna get another batch of solution going, and we'll see how the clarity of the solution pans out. Let's get to it. Solution here, and drop a piece of silver in that waste that we poured off.
piece of sterling.
I'll probably let that sterling sit in there for a day or two at least. See if I notice anything. I'll probably put that back on the heat too as well, just to fire it up. Get the molecules active. Alright, while our solution comes back up to temperature, I'll pull the camera away and come back to it when there's a significant change. Alright, well, as you can see, our solution has taken on some color, and it's cooked here another 2.5 hours. We have some intermittent bubbling, which I believe is due to the temperature. However, I'm not 100% certain, so what I'm going to do is I'm going to pour off this bit of the solution and reset the solution with fresh ingredients. So let's do that now. Well, our reaction has ceased. There's no noticeable color change to our solution. This batch has been boiling for going on 2 hours, about 1 hour and 50 minutes. And all action has ceased. So what I'm going to do now is I'm going to turn off the heat, let this cool down, and when it does that, I'm going to pour it off, and we're going to wash this gold off, make sure we have all the silver nitrate off of it. Silver nitrate was created by dissolving the silver in the nitric acid, and we don't want any traces of that moving forward as we mix up our aqua regia. I say aqua regia, but we're not technically using the standard aqua regia. We're going to use hydrochloric acid and then small increments of nitric acid to fulfill our goal. All right. One thing you really shouldn't do. Let me turn down the heat so it can start while we're chatting. One thing you really shouldn't do while the inquartation process is happening is to poke and prod at this stuff. You know, when we threw it in there, it was a solid metal. You throw it. If I would have just dropped it in the beaker, it'd have cracked the bottom. You know, so it had some weight. It was solid, and you don't want to be poking and prodding at it. If I squish it down, squeeze it, break it, I'm gonna dent it. And, you know, and what we did by creating the inquartation process, 1 part gold to 3 parts base metal, is you're creating a lattice, a framework that, imagine rows and rows and rows of scaffold all put out in front of you, and you start plucking out some of the bars here and there. Well, that's going to get you to the areas you got to get through. You know, some of there's still going to be a framework, but you're slowly pulling out piece by piece. And now if you go and dent that, if you crush down on your scaffold, it's going to bend and create points where you can't pull the bars out. It's going to block it. So that's basically what you would do here if you start messing with it. But now I think we're to the point where we've pulled out all the base metals that we're going to pull out. And now I just want to give you an idea of what happens when you do poke and prod at it. So See it crumbles rather easy. Does not feel like a solid metal anymore. So if you're taking a solid piece of metal, you're pulling bits and pieces, atoms and molecules out of it, you're left with this basically hollow framework, this scaffold behind it. Well, then you can imagine it might appear that we have a lot of silver here, or a lot of gold. But you can imagine if I can put a glass rod through it just by giving a little poke, you can see it's almost like it's not like the density of styrofoam, but you can imagine styrofoam. If you take a big chunk and you crush it down, you're going to have a much smaller piece if you crush it down to, say, the density of wood, right? So this is what you're going to be left with here, is that line of gold is going to come down to just 10 grams of gold is not a very large size. So, and that's what we're going to yield. Our yield is going to be under 11 grams of gold. So, yeah, that's going to shrink down. So at the very end, we're going to have a beautiful piece of gold. But this what we're looking at now is deceiving. So let's let this cool down. I got to give it some time and get set up for the next stage. All right, I think we are where we can be here. Let's pour this off and start rinsing our gold. All right, and all I did there was clean off the sides, get the bulk of the material off. We're going to give it a few rinses by actually boiling the gold in water now. So we're going to crank the heat up. I'll let that boil and we'll check back with it when it gets going. this should be our final rinse. I boiled it off 4 times. Should do the trick. Turn our heat off here. It's going to go back on in a minute, but here we go. Here we have our inquarted gold. Just about perfect. All right. All right, I just poured about 250 mLs of hydrochloric acid into our vessel. And I'm going to put the heat on low. Just to start warming this back up. And while it's getting warm, I think we can just start with a few shots of nitric. About 2.5 ml. Another 2.5 ml. Got 7.5 milliliters of nitric acid. We're going to let that warm up and incrementally add doses of the nitric acid as needed. All right, let's let that warm up. I already can start to see a reaction. You'll start to see a yellowing, and it's going to turn into a beautiful golden color. Alright, our reaction is starting to stall. At this point, I'm going to check the temperature and add a little bit more nitric acid. I'm also going to add a 0.5 ml of concentrated sulfuric acid. And what that will do is, well, in Karat Scrap, it's very possible that you can come across some lead, either mixed into the karat alloy that they created, or more likely within some sort of solder that they use to put things together. So if any lead does sneak through, the sulfuric acid will bind with the lead and create a lead sulfite. And yeah, so let's get started on this here. Lowered the heat a couple minutes before I did this, and it's down to 140. So let's just do this right away. For right now. Incremental doses. That's what we want to stick with for right now. Right. Adjust this temperature. And we will let that get back to work. Alright, our reaction is slowed down a little bit here. I thought now would be a great time for a stannous chloride test. This is where we are going to verify that we have gold in solution. I can tell by looking at it. I know the process and I know that it's there, but it's just part of the practice. You need to verify things as you're going along. And one of the things what I'm doing is I'm not verifying that there's gold in solution, but later on I'm going to verify that I dropped all the gold out of solution. So say later on I test it and I get a false negative and I didn't know, well, and my solution is bad. Well, this way now I'm testing my solution as I go. So when I do test for that I dropped all the values out, I'm going to want to know that I have faith in my stannous chloride solution. So let's do that now. Pull one of these out of there. We're gonna get a small sample. Here we have a little tinge of color, and we want to verify that this is indeed gold. So if it is a positive for gold, we'll see a nice dark brown color. Boom, there we go. Nice and rich. Close this back up. Now most filters and everything else you're going to want to keep. We recycle everything, get these values back. But this tiny sample we're not getting back. Stannous chloride has
has some things in it that you don't want to mess with. You don't want it going back into your waste disposal or your recovery pot. So I'm going to get rid of this, and we will test again. When we go to drop these values out of here, we will test again for and hope for a hope of a negative test, which would just show up as clear. All right. I actually had to walk away for a minute, so I turned the heat down. That's one of the reasons that the solution stalled out. So, but now I'm back. I turned the heat back to where it's supposed to be, and I can see bubbles already starting to come off of our gold. So there's still free nitrates in our solution. I'm gonna let it work, get up to temperature again, see how that goes, and if it quiets down, I will add more nitric acid. But for now, let's just let it heat up. Well, we have 3 or 4 tiny little pieces in there, and I've been letting them boil away for the last 45 minutes, and they're slowly getting down there, but I think I've reached a point where I'm going to add another half a ml of nitric acid here. Try to burn these off. Should have did that a half hour ago. But I'd like to know for sure that the least amount of free nitrates are floating around in that solution when it comes time to drop the gold back out. Alright, so we'll let this thing cook for a few more minutes, and if we need another half ml, then we'll do that. I have us all set up here to filter off our solution here. We're going to try to clean this up a little bit. I'll be honest, it's a little uglier than I was hoping. Oh, look at, I just caused a reaction here too. What did that? Clean gloves. Silver on here. I don't know if that's silver chloride. Or if that's just a reaction to water. Well, was it me that was saying I wasn't too happy with the color of this? Let's see what we can do about cleaning it up. That is not what we were shooting for. I'm not going to use the vacuum on this. Just going to use patience. think it's going to get, unless whatever just precipitated out clogs the pores, but I had something similar to that happen a while back, and back then I just assumed it was some sort of contaminant that I introduced, a silver, but it was when I sprayed water in. I'll have to figure that out. I think it might be a temperature thing. It is cold here today. I think it's like 1 degree right now outside. And part of my lab, when I built this fume booth, I didn't want, when the fan's on high, it sucks a lot of air. It moves a lot of air. So, and I didn't want it to empty my lab of heat every time I turned it on. When I'm working over my bench, that's an open fume hood, and you know, you do what you got to do. It sucks a lot of air out too, but this, I thought, if I can contain it, great. So instead of, when I close this door, it still needs an air intake. Well, that's what this vent is for in the back. This is outside air coming right in. So I close the hood, you see those flaps pop up, I'm getting fresh air and it's sucking through, and it's sucking right back out to the roof again. So yeah, so it gets kind of cold in here, and that can mess with things a little bit. I don't know if you can't see now behind here, but we poured that silver nitrate solution off of our base metals that we took out of our scrap gold here, our carat scrap. And I'm getting little crystals forming in there. That's due to the cold as well. Silver nitrate crystals. That's alright though, it's easily soluble. This is going to take a while, so I can't just keep chatting through it. So I just want this filter to collect everything possible, and I don't want that vacuum to assist in pulling anything extra through. Alright, so we'll let that filter through, and we can take a peek at it in a few minutes, and we'll get an update when it's done. Alright, this is finally mostly filtered through. Got a couple little particles there. What I'm going to do here is filter this through the same filter one more time. Very often, once you filter something through your paper filter, the little pores fill up with particles and kind of clog it up just a bit. And your second pass is often a little clearer, because those particles that are stuck in the filter help to capture more particles. So we'll let that drain off and check back with it when it's done. filter is pretty cleaned out here. Definitely captured some stuff that really I wish it wasn't there. That second filtration did very little. I'm sure it did. I'm sure it did help. The filter is packed more with more particles, but gosh, that is not pretty. That is not typical. That looks nice, but boy, when it's all together, you see its flaws. It's way darker than I'd like to see it. Way darker. Dirt on the outside there. What I think happened was when I created the shot, I wasn't thinking. I just poured some cold water and I set it out there. This time of year lately, I've just been setting it outside for an hour to chill, and it's perfect. That's all I need, especially for just a little bit, for like inquarting gold. Anyhow, the water was too warm. I ended up with quite a pretty good sized blob of our inquarted gold. Normally, if I had something like that, I would just toss it right back in the melt dish, melt it back down, and scatter it into tiny shot. That's what I'm used to working with. But for the sake of these videos, I thought, well, if problems come up, you just kind of roll with it, because and then you got to deal with it, and you figure out different solutions. But in this case, I think what it led to was that the chunks were so big that perhaps there was areas that the acid just didn't reach and didn't clean out. It definitely has a greenish hue. Platinum group metals can make a funky hue too, but I really don't think that was in anything that we had. All right. I'm gonna get set up, get our SMB ready, and we're gonna precipitate this gold out of solution here. I'll be back in a flash. All right, let's get this gold out of solution so we can go through these steps again. What I have here is sodium metabisulfite, SMB, and that's what I'm going to use to drop this gold here. If I still have a lot of free nitrates in our solution, I'm going to get this big frothy mess. If I don't, it's going to kind of just bubble a bit and sink down. We'll see a dark precipitant come out and drop out of solution, and I'll drop a few of these scoops in there until I see the color change. Maybe you'll see it too. Yeah, let's just get to it. Sometimes you learn best just by watching. I think we're doing good with the free nitrates. We're going to see this turn black real quick here. Once it's all dropped, it kind of changes. There we go. Yeah, we should be good here. Let me stir this around. think as a rough estimate, it's safe to say you need basically, give me 1 second here. It's gonna get louder in here. Need to turn the fan back on high. This is about the stinkiest process you can get here. And I do not need it in the lab. I think it's hard to tell with this one. I still kind of see a little bit of yellow in our solution, so I'm not certain if we dropped all the gold or not. So that's perfect. We will do a stannous chloride test. A little drip of our solution. Actually, doesn't look too bad. Looks good. Tested negative, so our values of gold have dropped. I'm going to get this SMB out of the way for now. It doesn't look very pretty right now, but I say we give this time to settle. What I could do right now is I could go right to the filter and I could start filtering this out. It would take a while. That fine powder clogs up the filter and it just, it takes forever. And this kind of filter, you can't put a vacuum to it because it'll just blow a hole right through the center. So our next step is to just let this settle so we can decant it, and then we'll filter the bunch at the bottom all at the end instead of dirtying our filter and cleaning it all through. Yeah, I'll show you on the next step. But yeah, I've been up now for well, it hasn't quite been 2 days, but yeah, so I'm running low on steam, so I think I'm gonna pull the pin on it for tonight. I'd like to keep going, but I think in order to have a good day tomorrow, I better hit the sack. So with that said, I'll check back with you in the morning. And by then, this solution should be all settled. Our gold will fall to the bottom and we'll have more just a clear liquid floating on top. We'll pour that off and filter it out. And we'll take our precipitated gold and drop it back into some AR and dissolve it one more time. See how it looks, and we might just do it for a third time as well. Alright, and then catch you on the next step.